Hello, what's up, my people? Hello, everyone. Keep on dropping your cross, your aspired career. I'm coming. I want to change the bulb. So after I change the bulb, but I don't want you guys to be down there doing nothing. So instead of that, let's do something. Drop your aspired career. That thing you trust that you will become. Whether you be a lawyer, there can be a lawyer in this comment section. So whether you're going to be a doctor, is he a surgeon, what is it called, a nurse, whatever you want to become, drop it in the comment section. Yeah, our electrical engineer is changing the bulb so we can have a brighter bulb. Do you want to say? No jokes, no jokes. Let's get very serious now. Let's get very serious now. Yeah, pharmacist or me to put the food and see you. I pray that you succeed in that career you choose. Let the course keep on coming. Let your career keep on coming. Just shut up there, for you. Who the hell is that person? Be serious, yeah, no jokes, yeah. Medical doctor, all over your praise. Medicine, real good, Jesus lover. Keep the courses coming, keep it coming, keep the careers coming. Yeah, I think it's more bright now, right? Keep it coming, please. That's the first. Pharmacy, Abdul Rahman. I wish you the best and the best and the best of luck in that career. Keep it coming. Your faith, the trust you trust. Tap it there. Let's see it. Let's see it, huh? Keep it coming, boys. Is that all we have? I mean, we should have more humans right now with us. How come there are fewer? So nobody here is trying to figure out, okay, history, Rama, okay, software engineer, BJ111, best of luck. Medicine and surgery, Matt, best of luck. Nurse, Relok Abdumalik, best of luck in that, best of luck. Keep on dropping the emojis and your course and your career. Keep on dropping them. Okay, we'll be starting in 2 to 3 minutes from now. This board is funny. So you can get a perfect shot. I think it is okay. Okay, this is okay, I guess. If you're just joining us, the first task of today is to drop your aspired career on the comment section. Why is this not? Might make it portrait. Maybe okay. Okay, is my board clear enough? So we're gonna be starting in a jiffy. Wow, I'm so excited. This is gonna be massive. I don't want to. Wow, my mind all this while. Jesus, we starting show science on mute. So sorry, electrolysis catch my mic. I don't know my mic wasn't on, but it's on now, right? So I believe everyone can hear me. Huh? Are you ready, boys? Yeah, today is gonna be very, very massive. And trust me, let me tell you something. You can see the way I'm moving. Do you know what? I'm eating bread and seaweed. So now I can see way. I have eaten bread, so I have bread. And I've drank seaweed, so I can see way. So keep it coming now. And this is about you. And jokes apart, we're not ending this live class until you understand this topic, electrolysis. Are you ready for this? Are you ready for this? Okay, now this is what we're going to be doing now. I'm going to just check your comments. Yeah, this is what I'm going to be doing now. Hey Jesus, this thing is okay. I don't think this slide is necessary again. Now we'll start the question by explaining what electrolysis means. Okay, I think it's clear, right? Okay, good. Now we're gonna start electrolysis by understanding the two topics that are supposed to precede electrolysis. There are two topics that are supposed to precede electrolysis. What is it? Today's date is 17 to 2027. Yep. Now, the two topics that are supposed to precede electrolysis is what? Is balancing chemical equation, and understanding understanding redox reaction. Now, these are the two topics that also precede electrolysis, because electrolysis deals a lot with the redox angle of equations, which is what the oxidation side and the what and the reduction side. And for you to understand redox, you have to understand balance chemical equation. So, before I even define electrolysis today, let's start by doing a bit of revision into what we call balancing chemical equation. I want to be solving we're going to be solving four questions in SFP. So, I want you to pick your pen, your book. Like I always tell you, if you actually use class, this is how to do a live class. Whether you're a paid class or a free class, YouTube, Instagram, Twitter, whatever you're doing a live class, even if it's not chemistry or biology, your book and your pen in your right hand, your right-handed person, your pen in your hand, your book in this side, then this side holds your phone. Or if you're using a system, this side holds your mouse for your laptop or your system. Do you understand now? Or your desktop. So then preferably use earpods in the earpiece. You understand? Plug that in and then start blasting. So that is how to be in class. So if you are here and you're still switching, you're moving from WhatsApp status back to YouTube, from TikTok back to YouTube, you're switching between the future and the past. Trust me, you will deserve slap. Wait, oh my kid, I'm coming for you, because when I reach your house, I'm going to wipe you a Rimo cord. Sorry, Rimo cord is so expensive. I'll wipe you ITEL cord at the back of your neck, and nobody can do this shit. So you're supposed to be focused right here. You're here or you're out. So if you're ready, let me see it in the comment section. I am ready. If you're ready, let me see it in the comment section saying I am ready. I can't say it, boys. Bring it up, boys. If you're ready, let me say it now. Yeah, I can see you keep it comment. Yeah, this is beautiful. Exactly. Keep it comment. I would suggest to you that if you have a friend right in this live class, ignore them because they don't exist. And they're probably just here to catch cruise. You're not here to catch cruise. I am not standing here to catch cruise. I'm here to teach you. I'm here to learn. In as much as our teaching and our learning can be switched together, and we can actually enjoy it. At the same time, there's a purpose, there's an aim of us being here. We're not here to burn our data out, to waste our time, sitting on the phone, and this is one man on the screen blabbing. So if your friend is here with you, and in the comment section just dropping nonsense things unrelated to the class, ignore the person, because trust me, that person's brain is empty. And the only thing that brain now is what is bread and beans that are spoiled. Good. Let's keep on going now. So the first division we'll do is what is balancing chemical equation. So balancing chemical equation. Now let's take an example. According to balance conservation of mass, which is how to balance chemical equation. Now, how to balance a chemical reaction. How to balance a chemical reaction. Right? Now I want to teach you two, no, I'm going to give you three major points in balancing chemical equation now. Number one, always target the what? Oxygen and hydrogen. Target those two first. Always target oxygen and what? Hydrogen. Write that down. Please, what is complaining of network? Yeah, BJ, I think you're my biggest fan there. I love you, boy. Who again? Which name is common here again? Yes, Oroloka of the Malik, I'm rooting for you, big man. I really a good luck. I'm rooting for you. I think there are a few ones I can remember. Yeah, Olabode Rachel. Yeah, yeah, living praise. Living praise. I'm rooting for you too. But every other human being that is just behaving like a foul, God knows on your wedding, there was spray money, but money enter your wife's pocket, not your own pocket. Nonsense and ingredients. I'm written that. Number one is what? Always target oxygen and hydrogen in your balancing. Then number two, always jump. Or number two, ensure, except in rare cases, jump to even number. Mostly what? Jump to what? Even numbers. Even numbers, almost all reactions are mostly in even numbers. So jump to even numbers. Because even the elements like oxygen and hydrogen can never or is unlikely to be what? To be odd number because it's diatomic, right? Then lastly, then number three, are you there? Are you writing? Okay, so I'm trying to see your messages. Please, I don't know if the network push me out. I want to know. So just find a way to reach out to me ASAP. Then lastly, the most common one. Always treat radical thing. Always treat radicals as one. Always treat radicals as one. Always treat radicals as one. Now listen up. You see, electrolysis is a very complex topic. I agree, but there's a way I'm making it very simple. And the thing here is this: is predecessor plus chemical equation. Today I'm using almost the same marker today. I don't know. Sun's not writing well. Is a black showing? It's not. It's not showing enough to me. The zinc. Okay, so it's predecessor, which is a balanced chemical equation and balancing redox reaction. Now, it's predecessor also they appear complex. But like I said, for exam purpose, not understand purpose. Now, exam like UTME, which most of you call JAM, exam like WASI, which most of you call WAEC, exams like the NECO, SSC. These exams are more of the test of how you can actually maneuver the trap. One and two, your speed, and then three, what your accuracy. So it's about what smartness, speed, and accuracy. These are the three things exam need you to be. So if you are smart, I don't know if you notice that most times the smartest person in your clique is always not the most intelligent. You copy your guy, the person that has offer in your clique that if there is a mango tree in the street and the owner of the mango tree is a soldier, he knows how to enter the compound, pluck the mango, come outside and share the mango. But it's always the most intelligent in the class. That's smartness. So exam need you to be smart. Meaning you have studied, we agree. You know it, we agree. You understood it, we agree. You remember it, we agree. But can you use all those agreements? Can you use them to answer this question? Yes or no? Copy. And exam is like this. This is the way exam comes in. Exam is like this. Are you following? Exam is like this. Exam will tell you that, okay, write A or write B. If I mention a country, write A. If I mention an animal, write B. And then the question will come as what? The question will say, okay, which of this is this? Turkey. And then what happened to you? Your spirit will first leave you, right? And then you'll be wondering why is your vehicle after you? Because this is exactly how the exam is. This is exactly how. Now you already know what's a country, you already know animals, but now look at the question here. Turkey, is it country or animal? Put it in the comment section. Country and Turkey, is it country or animal? The first boys. It's far? Okay. Oh. He's talking a country. Hey, this is say AB. Hey. Okay, I'm seeing that. Keep it coming. Keep it coming. Depends on the pronunciation. Olodo. Pronunciation for pronunciation is. Let's continue. Now, none of it. I mean, copy is most cultural animal, but that's not the point now. The point is this is exactly what exam does. Exam try to play with your head and all. Somebody said this thing is fast, so let me adjust to the beat. Then hopefully, I don't know if it's more okay like this. Okay, I think I need to check please. Is it more okay? Is it better? Is it better? Okay, I think it's okay this way, right? It's better, right? Good, now let's continue. So that's what exam is now. So which means you have to find a way to be what? To be very fast, speed. To be very, very what? Fast. Which is why I train most of my students using Kahoot and other special app out there. As some of you that actually use Test Driller, yes, there's Lazarus and just Test Driller. I love that app. I want to build that app. Yeah, we appreciate your work to an education sector in Nigeria or in West Africa. So the next is what is accuracy, which means as you are running, as you are doing, you can what be accurate. Copy. So these are the three things you need to understand to be accurate in vast migration. Always target first of all oxygen and what hydrogen if it's an equation. Number two, always jump to even numbers except when unnecessary. Number three, always treat radical as one. Always treat radical as what one. It's not radical. OH. So now you see OH. OH is what one. You need right now OH is how many? One. This is two OH. This 3OH. That's how to do it. It's not going to we have what? SO4 2 minus. We also have what? We have NO3 minus. We have NH4 plus. These are radicals. Treat them as one. Like just one element. The same way you treat cobalt. Same way you treat sodium. Same way you treat aluminium. Same way you treat chlorine. Treat them as one. So now with this being said now, let's take two examples before we rush down. Trust me, like I said, we are finishing this live class. We are finishing this target of electrolysis today and not tomorrow. So let's go now. Don't forget, share this link right now as I'm in the class. Share it right now to your friends, to your classmates to join this live class. We are finishing electrolysis today. Now, let me just give you one example. Two examples. One simple one and one complex one. Yeah, let's use this. So we have Fe plus O2 to give us Fe2O3, right? Now in this case now, in the reactant side, we have a element we have two substances. We have Fe and we have O. In the product side, we have what? We have Fe and we have O. How many Fe have in the reactant side? Look at, according to the law of conservation of mass, you cannot create energy. You cannot destroy energy, right? That cannot be created and be destroyed. Same thing as matter. You cannot just change from one form to the other. It applies here too. The number of iron you have here, which is Fe, the number of Fe you have here, it doesn't change. And you're not allowed to change the subscripts. What subscripts? This number here is the subscripts. This number here, these small numbers. Do not change them. Only change this place, the number in this place. Currently, there's no number there, so which means in chemistry, there is one there. Only change the number here. The number one here. Yes, that's the number you should change. Do you copy now? So currently, according to this box now that we have on the board, we have one here, one here, one here. So anything you put here, multiply everybody here. Anything you put here, multiply everybody here. Anything you put here, multiply everybody here. So if you look at it now, 1 times 1, iron is what? 1. Oh, are you following? Then this one here times 2. Oxygen is what? 2. This one here times 2. Iron is what? 2. This one here times 3. Oxygen is what? 3. So in this case, now is it balance? Capital letter no, small letter no, capital letter no. Copy? Good. Now, so iron here is 1, iron here is 2, oxygen is 2, oxygen is 3. And let's balance. What did I tell you? Always treat oxygen and hydrogen first. Let's balance oxygen first. Oxygen is 2 here, oxygen is 3. So here is more, here is less. So increase this 2 to what? Increase it up. Now you have 1 here. Change it to what? 2. Change it to what? 2. So you have, like I said, always jump to even numbers. Don't just jump from 1 to 2. from 1 to 3, except in needed cases. Now, this 2 here now, and 2. 2 times 3 is what? Type it out. 2 times 3 is what? For some of you don't know it. What is my k itself? Oh, where's my k? 2 times 3 is what? Type it out if you are still with me. 2 times 3. Wow, living place. I like this girl. I need to buy you a new smartphone. You are very fast and attentive. You are focused. Yeah? Small collect, you are the second. Any other person that type here, counterfeit. All of you are late. You are late. You are not here. After typing, okay, yeah, I can see your answers. Thank you, thank you, thank you, thank you. So that is what? 4. Something is not what? Something is 4. Copy? Something is 4. Now, so which is something is not balanced here again. Like I said, always balance something first. Something here, that's the cocoa. Like you put 2 here. You know, yeah, there's only 1. Put 2 here now. Why is this thing not writing? Why is this black not writing? Oh. And this 2 now, I've changed it from 1 to what? So it was 1. We raise 1 and put 2. So times 3 now is what? Is 6. Also, balance 4, 6. Then change something again. Put from 2 here, put to 3. So all the black are not writing. So put 3 here, because 1 times 2 will give us 6 is 3. So 3 times 2 now, 6. Also is not balanced. But before we come here now, let's go back. There was 2 here, also is 4. Back to this place. Let's go back again. Back here. So there was 3 here. Now I said we should put, because also here is 3, also here is 4. So here is lesser. What we put this one, right? And the reason why I put 2 here now. Now 2 times this 3 also become what? 6. But then that 2 affects both iron and oxygen. So now how many is iron now? 2 times 2, that's what? 4. Now, like I said, here iron is 1, iron is 4 here, oxygen is 4 here, oxygen is 6 here. So which means oxygen is not balanced. Leave the iron in the focus on oxygen. Now, change this 2 here to what? 3. Now 3 times 2 is what? 6. Something now was balanced. So the next focus now should be what? Should be iron. Now iron is 1, the iron is 4. What we put to is 4. Just put 4 here. 4 here, how many is here? 1. 4 times 1, 4. Iron also wants balance. Now if you are here and you are learning this for the first time, if you are learning this for the first time, trust me, the only thing you should do is don't be scared. Keep on increasing the number here. This place. Keep on increasing from 1 to what? 2. From 2 to what? 3. 3 to 4. 4 to 5. 5 to 6. 6 to 7. 7 to 8. Till you reach 121. Till you reach what? 121. It's not correct. It's correct. If it's not correct, tell me say it's correct. I will slap you for face. You tell her I'm my teacher. I am the teacher. It's not correct. It is correct. So that's how it works. So the balance equation will become what? Will be 4Fe plus 3O2 equals to what? 2Fe2O3. So here we have 4 iron, 3 times 2, 6 oxygen, 2 times 2, 4 iron, 2 times 3, 6 iron, and 6 oxygen. Now this number here affects everybody. So let's do number 2 example. And number 2 example that we'll be doing now is this. Let's do the combustion of what is called of ammonia. Combustion of ammonia. So ammonia is NH3 plus O2 to give us. Let's do partial combustion. NO. Let me manage this board. Out of the board, please. I need to rub it off. So I don't know if you need to jot it down. Be fast. Jot it down. I need to rub it off in 10 seconds. Good. I think that's enough. Let's continue. There is no time to check time. I'm not going to electrolysis. So we are still doing the introductory part to what you need to know electrolysis. To know electrolysis, yes. Okay, so let's do combustion of ammonia. So ammonia is NH3 plus O2, which is combustion. Mind you, combustion just means addition of oxygen. The other addition of oxygen is not combustion, is roasting. And that's it. Then partial combustion, this is NO2. So NO, sorry, NO plus what? H2O. This partial combustion of ammonia. So now which means you're changing the number here, right? Remember? I'm changing the number here. I'm changing the number here. Remember? I'm changing the number here. I'm changing the number here. Now in this case, now can you notice something? Like in this case, the equation is a bit more complex than the first one. We have two reactants, two products. And these two products here, we have oxygen here, we have oxygen here, so there's a problem. So you have to be very, very careful if you want to solve this one. Are you ready? In this case, now let's write out the substance involved. So we have nitrogen. Nitrogen is what? We don't know yet. Okay. We have nitrogen, we have hydrogen, we have oxygen. Right? Yes, we have nitrogen, we have hydrogen, we have oxygen. How many nitrogen do we have? We have one. How many nitrogen? We have three. How many oxygen? We have two. Let me do it again so you can know. Nitrogen is 1 times 1. 1 times 1, 1. 1 times 3, 3. 1 times 2, 2. For nitrogen here, 1 times 1, 1. 1. 1 times 1 here. So we have oxygen here, we have oxygen here. 1 times 1 here is 1. 1 times 1 here is 1. 1 plus 1, oxygen is 2. Nitrogen, 1 times 2, 2. Should I continue? You are straining your eyes. What happened? Is this the far or is it the writing? Living place, is it the writing or the color? Which of them? Is it clear now? Is it okay now? Are you sure it's okay now? Is the board showing very well now? I'm trying to reduce the strain of the eyes on the eyes. I don't know. Please, I need confirmation. How is it now? Yeah, the issue is the board itself. The board is in a more of a portrait format, so it's very hard to capture everything. I think this is better now, right? So check it for me. This is actually consuming our time. How is it now? Is it capturing it? Is it okay now, sir? Oh, okay. It's okay. It's alright, sir. I've changed the word it's called now. Now the connection, right? It's alright. Okay, you guys, let's continue. They could not even finish the board. How is it now? Is it okay now? Oh, Jesus. It's okay. Okay, let's fight then. Where do we stop? Yep. Marcus. Oh, it's all right. So we have now 132, 122. Now how do we do it now? Like I said, the first thing I said is what always focus on hydrogen and oxygen first. In fact, oxygen should be your priority before hydrogen. No? Oxygen should be your priority. Then priority one, priority two. I think this is the last example I'll give for today, and I'm going to give you one classwork to actually one exercise to actually do. So let's start now. Oxygen is 2, oxygen is 2, so oxygen is balanced. Hydrogen is the issue. Hydrogen is 2, hydrogen is 3. So if here is 2 and here is 3, we're increasing this size, right? This side. Now, it's going to be 1 here. Let's move it to 2. So let's move it to 2. 2 times 2, 4. Yeah, that's oxygen. 2 times 1, 2. Plus this 1 here, 1 plus 2, 3. Oxygen has changed. That's first step. And the next step now is this, right? Oxygen is an issue again. Let's make oxygen 2 here. There's already 1. Put 2 here. 2 times 2, 4. You see it now? Now oxygen is an issue here. So now if oxygen is 3 here, oxygen is 4 here. Oxygen is 2 here, oxygen is 1 here. Also let's put 2 here to make it balance. So 2 times 1 here, 2. 2 plus 2, 4. But this is also affect nitrogen. 2 times 1, 2. Now hydrogen is the issue, right? Hydrogen is 4 here, hydrogen is 3 here. Let's put 2 here. 2 times 3, hydrogen is now 6. This 2 affect nitrogen. 2 times 1, 2. Are you following? Now hydrogen is not the issue here also now. 6 here, 4 here. Change it to 3. 3 times 2, 6. Don't forget, this 3 also affects oxygen. So 3 times 1 here, 3. Plus this 2 here, 5. Now we have 5 here, we have 4 here. This one is lesser. Put 3 here. 3 times 2, 6. If you notice something, we are doing the same cycle. And it makes it very, very easier. I will not drop it, I will not capture it up and down. Then this one is 6. Put 3 here again. 3 times 1, 3 here. Plus this 3 that I said before, that's 6. These 3 affect nitrogen. 3 times 1, 3. To me, I'm actually not bored. I read it till I get it. Some of you are always impatient. You just bebelube, umbe. You be jumping like, oh yeah. Deep down, huh? Now in that case now, nitrogen is the only issue here. Nitrogen is the only one that's the issue here. 3 here, 2 here. So change this place to 3. And everything will scatter again. It's like Nigeria. If they do the light sector, network will not good. If network is good, battery, one thing will happen. Like some people are using ITEL here. ITEL user. Oh, Jesus. Okay, so let's put 3 here. And you need to put 3 here. 3 times 1, actually become 3. But this 3 also affects hydrogen. 3 times 3, we have 9. Let's start again, right? So hydrogen is the issue. How can we make 9 here? It's not impossible, but not use even numbers. So put 5 here. You know I jump from 3 to 5? Because if I put 4 times 2 is 8. It's still less than 9. So let's put 5. 5 times 3 is what? 10. So what is 5 also affect oxygen? 5 times 1 here is 5. 5 plus this 3, 8. Now, in that case, now oxygen is the issue. So let's put 4 here to make oxygen also 8. Now hydrogen becomes the issue. Hydrogen is 9 here, hydrogen is 10 here. So put 4 here. 4 times this 3 of hydrogen, it becomes what? 12. This 4 also affects nitrogen. 4 times 1, 4. Nitrogen is the issue here. 10, 12. Put 6 here. 6 times 2, 12. Now this 6 affects oxygen. 6 times 1, 6. Plus this 3 here, that's what? 9. To make it balance, this also has to be increased. Put 5 here. 5 times 2, 10. Right? Now 10 now. How much is hydrogen is in balance here? You know, we have 9 here, we have 10 here. Now, so when it increases, so let's increase this size also. Put 4 here. 4 times 1, 4. 4 plus this 6, makes it 10. What is 4 of nitrogen? 4 times 1, 4. What am I seeing on the board? Wait, it seems like magic. We have 4 here. We have 4 here. We have 12. We have 12. We have 10. We have 10. So it's balanced. So the balance equation will become what? The balance equation will be 4NH3 plus 5O2 to give us 4NO plus 6H2O. Now this is it. That's the balance equation. Now I want you to do this one by yourself. I'm going to give you just 2 minutes before I go back to what we need to do today, electrolysis. Do the complete combustion of ammonia, NH3 plus O2. Should I give you that one? Okay, let's do it. Plus O2. Oh no, this is 2. Al plus O2, combustion of aluminum, Al2O3. Yeah, do number 2. NH3 plus O2 to give us NO2 plus H2O. Now just give me the ratio. What's the ratio? The ratio for this one is 4:5:4:6. That's what I want you guys to give me as a final answer. So be very fast. Okay, I'm going to tell you to do it, so we have just a very short time to do it, and then we'll come back to this baby boy. But fast, I'm reading your comments, that's why I just paused. Do those 2 very fast and tell me your ratio. Don't use AI, don't use ChatGPT. You don't really need to cheat. If you need to cheat, you need to be in the first place. Just do it by yourself. If you have any question before the others are done, drop it for me. Let's get going. There's no time, huh? So while doing that, I don't know. I think we should change. Should we go to the other board? Well, you have enough space. They are done with the board though. Give it just a few more minutes. Please be fast. I think we should be done now, right? Can we see the question? Can you see the 2 questions? Okay, I think we should be done, right? But you're not done. Okay, be fast, please. Just increase your wait. I don't understand. Can we see number 2? Hello, can we see number 2? There are 2 questions. Wait. What are they answering since then? Is it number 1 they're answering? Oh Jesus, this is number 2. Can you see it now? Please write it out. You are leaving this board. So the answer for number 1 is, let me balance it. That will be aluminum and aluminum. That's 2 here, then 2 here, 2 times 3 is 6, then 4 here, then that's 3 here. So the ratio will be 4 ratio 3, ratio 2. That's the answer. 4 ratio 3, ratio 2. Aluminum is 4, oxygen is 6. Yeah, correct. So do the ammonia on. NH3, let me shift the level for you guys. NH3 plus O2 to give us NO2 plus H2. Thank you, Abdurrahman. I don't know whoever that person is. Thank you for telling me. I really don't know. No, number 2 is not the same thing as number 1. Though. If you think number 2 is the same thing, it means you're not in this class. It means your brain is somewhere else. So you need to go and eat. They're not the same. Look at it very well. Check it very well in your notes. If you have it in your notes. They are not the same. I'm getting excited, ignited. Oh God, my spirit is ignited. What? Okay, we are leaving this place now. Let's go, boys. I'm not using this class again. Let's go to the other class. Bye bye. Can you see our tutorial? Oh, this is our tutorial. Uh-oh. Yeah, look at empty chairs and empty benches. Now this is where humans sit. But for this evening, I'll be teaching ghosts. You can see them. Can you see them, everybody? Those are ghosts. We call them G-O-S. Oh no, sorry, G-H-O-S-T. Now these are ghosts. And look at plier. This is one ghost uses plier. Uh-oh. So this is where we are coming to now. Yep. So this class will be used now. So mind you, my fellow ghosts, this is the class we'll be using now. So let's check if it's perfect enough. This board is a bit more bigger, and I think the light is more brighter, so we're gonna enjoy it more better. Where's my second phone? Let me check if it's okay. So have you guys gotten it? It's come and bundle you. Can ghost bundle ghosts? It's confidence. I just got a phone. What's this one saying? Okay, let me see it very well. Okay, it's not showing all yet. Sorry, sorry. Just keep on increasing the number of oxygen and hydrogen. Focus more on that, and then you will get it sorted. By the time I'm done setting this camera, I'll be giving you guys the answer. I'll move to electrolysis on board today. At least your step 20, you still have enough time. If you want to go to sleep, go to bed. This night is for us to smash electrolysis. Wow. I think it's clear now, right? Let me check it. Okay, yeah, this is beautiful. This is beautiful. You are lost, okay? Don't be lost. So we can't find people at night, so don't be lost. Don't be lost because oh. Okay. So the answer should be 4:7, ratio 4, ratio 6. Can you guys hear me now? I hope it's clear. Somebody, thank you for calling me. That person that called me, thank you. So, okay, yes, the mic is on now. The mic is on. Thank you. The mic is on. Thank you. Thank you. Show. Okay, so the answer to that question I gave to you guys earlier is 4, ratio 7, ratio 4, ratio 6. 4 ratio 7, ratio 4, ratio 6. That's the answer. Okay, good. So I'm gonna got it. I'm back. I'm gonna got the answer. I'm now on the board. I'm on the board. I can see your messages now. I'm gonna got it. Master, explain that number 2 because I'm getting 4 ratio 5 ratio 4 ratio 6. No, can I 4 ratio 5? 5 times, if you say 4 ratio 6, what means there's oxygen? Oxygen is 2, yes, NO2. It's NO2. There's nothing of you explain anything there. It's NO2. Oh, you got it, Fabody. Nice one for you, Shay. You got Fabody. So if you got it, nice one. That's a good one there. Where again got it? Yeah. Oh, Monda, yeah. Jesus. I hope I pronounced it correctly. Nice one for you. Where again got it? Oh, Kwayami, yeah. Thank you. And because you disturbed the ghost, living place. I've heard you. You said disturb the ghost. Okay, so any apart from Rose Jane, right? There is a yeah. Another person with the issue now. Calm down and do it again. You also get it. All of you are saying me too, me too, me too. Yeah. You rock more. You don't land more. Continue deceiving yourself. Oh. Everybody is me too, me too, me too. Call me 24. One of me 3. Is there any me 3 there? Any me 3? No, the product is what is it called? The product is NO2. Okay, we're done with that. Now, if you actually understand how to practical equation, I understand. Sorry, I understand redox to a large extent. Then trust me, you're already a step away from understanding electrolysis. You are what? A step away from understanding electrolysis. Now let's start now. You see, electrolysis is just a ball game. Electrolysis is just a game. It's a game between chemistry and physics because basically we have come to understand what electricity is a physics based topic. Are you following? I come to understand what that physics sorry, I say physics that electricity was a physics based topic. And let's start. This is all we're achieving today. I want to be able to see your comments. Let me put it here. Now, this is what we're trying to achieve today. We're trying to achieve number 1, the introduction, the meaning of electrochemistry. Number 2, the cell components, the basic terms, the electrode process, the electrolysis itself, the special sort of ions, quantitative electrolysis, the Faraday law of electrolysis, function of electrolysis, and application of electrolysis. And trust me, this night you're going to do all this shit. Are you ready? It's funny, right? It's actually funny. Okay, I don't know if it's actually straining your eye, but if you are doing, please just let me know so I can actually, enlarge my writing or something or find a way to ensure that the light is doing a good job. Everywhere is blur. How is it now, Malik? Is it okay now? Is everywhere still blur? Is it still blur? Is everywhere still blur? Can you check it for me again, please? The writings are tiny. Yeah, okay, thank you. The writings are very tiny, but I'll increase the size of the writing first. So we're doing the introduction now. Let's start now. This is the point. This is the point. Now you see, electricity, the first time we discover, or okay, I will say the word discover, or realize that there is something like electricity. Hey, Jesus Christ. Oh God. Hey, I am about to smash some students' head. Oh my beautiful God. Have you seen the outline? Write the outline so we know what I've covered and what I've not covered. Write the outline, write the outline. I want you to write the outline. Write the outline, write it, the first. Write the outline. So these are what we're going to be covering. So next one is basic terms. Next one, electric process. Next one, electrolysis of substance. Then enter molten compounds. Then enter aqueous solution. Then enter preferential instead of ions. And let's stop here. Okay, so I'm going to increase the size of better. Yeah, I will enlarge my writing, yes. Now you see, when we actually first got the idea of something called electricity, hmm, it was from the angle of something called electron. That is why the first mode of conduction of electricity, or the first mode of electricity being generated or designed or understood, was from what? Was from metallic conductors. Metallic was conductors. Are you there? Do you understand now? Because electrolysis is not electricity in metallic conductors. Electrolysis does not in any way deal with what conductors. Electrolysis is electricity in another mode entirely, another medium entirely. So the first time we discovered or we understood electricity, it was from the angle of what? Electron, which means electron flow or the flow of electron was actually the meaning of what? Of electricity. Are you getting the point? So electron flow, someone say electricity, just simply means what? The flow of electrons. But then the more we realized or we discovered then was solid means. So only solid means is where we get electricity from. Until my big boys came around. People like Professor Fabo de Sherito, people like Sir, Real Boots, people like Mr. Living Praise, people like Mrs. BJ, the people in my online class, huh? People like AKA Tinubu. Until when I came and realized that, okay, wait, the only electricity we need what is solid medium, meaning where electricity can only be conducted through what solid medium. So we call those things that allows the flow of electron. The solid now, those solid. Oh Jesus Christ, this thing is getting more heavy in my head. I need water to cool it. So with all them, you see, there are three solid in my hand, right? Now today is not palm oil. There are three solid in my hand. This solid here allows the flow of electron, meaning this solid here allows what? Electricity. And I said what? Allowing electricity means what? You are doing conduction. So what do we call it? We call it conductor. Meaning this solid here is a bero soko. Bero soko. What do we call you? Conductor. Oh, are you getting the point? So when a metal, sorry, my writing is already small again. Sorry, when a metal conduct electricity, what do we call it? We call it what? Conductor. Conductor. Are you getting the point here? Are you getting the point here? So from the word bero soko, it carries people into the place. So it allows the what? The flow of electron. Because the flow of electron is the what? Is the flow of electricity. So the more the electron flow, the more there's electricity. Now this one is what? Is conductor. But you see this one, the blue one. The blue one does not allow the flow of electron. Allows the flow of electron, meaning for it to conduct electricity. He said no. This guy is stinging. He's like most of you here. So what we call it insulator. What I say? Call it what? Insulator. So insulator are solid or materials that doesn't allow the flow of electrons. Bam. Then this is what we call it semiconductors. They allow the flow of electron partially. For example, all those odd elements like boron, like germanium, like silicon, like hey, write it down. Hey, those are the ones, boys. Those are the ones, boys. Now, then we crafted a new version of electricity where another medium or another state of matter can conduct electricity. You know, we call that state of matter, we call it what? We call it, we call that mode whereby we can use a special state of matter to conduct electricity. We call it what? Electrolysis. Now, instead of us using, I'll have just maintained that other class. I'll have maintained it. Since this one, trying to make it big, actually, make the board far from the students. I'll have maintained that class. But there's no time. This Bob issue actually messed up a little bit today, but we can't just have to make use of what we have. Now, so instead of us actually going further with the use of what? Of metallic conductor, there is now another means to actually create electricity or allow electricity to flow. And that mode is what? We use what we call electrolyte. Through a process called electrolysis. Called what? Electrolysis. Now, what's electrolysis? Electrolysis is the process in which a chemical change is caused by what? By an electric current. Oh God, are you getting the point here? Electrolysis is what? Is a process in which a chemical change is caused. Some of you here, when I say, we have fun and be praise, and dance now. Today's your birthday, you're happy, you shake your body, you cannot shake your body. But the day you touch Okono, like you're doing, you're preparing one pole, and very one wire in your room, immediately the electric current enter, but what you do, you will dance. That chemical change, you will, you will dance. Now, the same instance here, we have a way this guy is. Electrolysis is the word. The process in which a chemical change is caused by what? It's caused by what? By the passage or the entry of an electric current. But your textbook defines it like this. Your textbook says electrolysis is the what? It is a chemical decomposition. Write it down. First step is the what? The chemical decomposition of a substance. Which can be what? In a molten state, or an aqueous solution. By what? Passing electric current through it. By passing electric current through it, or direct current through it. So what's electrolysis? Let me check the step comment section. I don't know if it's clear. Electrolysis is the what? Is a process in which, is the chemical decomposition of a compound, which can either be what? In a molten state or aqueous solution by passing electric current through it. Through it. Through it. I think it's okay, right? Are you following now? Now, are you there? Now, you see, the process in which, I think there's no message again, so let me. Have you seen that? Now, you see, the first electricity that was actually understood, or was that we actually get to figure out, was the one whereby there is a flow of electrons in what? In the metal. And we call this one of metals what? Metallic conductor. But in this case, there's no flow of electron now. In this electrolysis, it's just when there's a what? A chemical substance being what? Decomposed by passing electric current through it. Now, that substance that allows electric current to decompose it, meaning, see these two compound now again. If I put electric current in this compound, it does not decompose. If I put it in this compound, it decomposes. This one that decomposes is called what? Electrolytes. So in a very simple way, you see, electrolysis, write it down. Electrolysis, electrolysis is equal to what? Consumes energy. That means we use what? We use energy or consumes electricity. Consumes electricity. My writing is small here, so just see what I said. Consumes electricity. Why galvanic cell, or sorry, electrolytic cell, in faith, why galvanic cell produces electricity? There are two different. There are two different things. No? Write this down. Electrolytic. Write it. Point one. Electrolytic cell or electrolysis consumes what? Electricity. Galvanic cell produces electricity. Write that down. Be fast. Be fast. Be fast. Be fast. Don't. Be fast. I hope you have just that down. Now let's ignore this place. Now let's come back here. So now I understand the angle of where our electrolysis is being derived now. This substance, let me explain what it means. You see, this substance that allows the flow of electric current is what we call electrolytes. This is what we call it. Electrolytes. So unlike the normal electricity that uses metallic conductor, the one we use for electricity is what? Is electrolytes. So number one difference between them. Now come back here now. One difference between them. Number one, a metallic conductor is in what? Is in solid state. Electrolyte is in what? Is in what? Is in liquid state. Number two, a metallic conductor is in what? A metal or graphite. I'm going to give you three or four. Why is electrolytes are what? They are non-metal. In what? Which is molten or what? Aqueous. How does metallic conductor conduct electricity? By what? The flow of electrons. This one do it by what? By movement of ions. By movement of ions. This one process is conduction. Conduction. This one is what? Conversion. Keep these four things in your mind. It will help you. Keep these four things in your mind. It will help you. Jot that down before move to the next phase. Jot that down before move to the next phase. You can't see it, K. Can you see it now? I hope it's clear now. The fast, please. Number one, I said metallic conductor are what? Solid state. Electrolyte are what? Liquid state. Then metallic conductor are metals or graphite. Non-metallic conductor are what? Non-metals, molten or aqueous. Metallic conductor are flow of electron. Electrolyte are what? Movement of ions. Metallic conductor is true conduction. Electrolyte is what? Convention. Good. Now let's go then. If you have written that, then there's no P about that again. Now, since we are done with that now, I understand what electrolyte means now. The next thing is to understand. Well, let me see. For those of you that write the outline, what's the next subtopic I need to cover now? Let me see if you're actually with me. What's the next thing on board? Type it up. What's the next thing on board? The SAP boys. What's the next thing on board? Who is this person just dropping emoji now? Okay, so nobody's going to get airtime today since nobody wrote it or write it down. So which means that's the first point for today, lost by everyone. Okay, let's pull through then. The next thing I want to learn is what we call the electrolytic cell. The electrolytic cell. The electrolytic cell. Now, this electrolytic cell now will help us to understand the two major guys, not even the basic terms of electrolysis. It helps us to understand the two major guys of electrolysis, which is what? Which is which is the cathode or the anode, not this one, which is the anode and the cathode. The anode and the cathode. And let's learn something here. This is electrolytic cell. So this is a simple electrolytic cell. So I'll explain and then we need to understand what happens at the anode and what happens at the cathode. First thing first I want you to understand is this. In a simple electrolytic cell, we have a battery, we have a switch, we have ammeter, and we have these two poles. Now in this battery now, there are two things. Or let me see. Is there any comment first of all? Can you hear me now? Can you hear me now? Hello, is it clear now? Can I continue, please? And also the board, is it? Okay, thank you so much. Now let's continue then. So now, so let's understand the each part of this, what is it called, of this cell. Here's the battery. Now it seems that that means that the battery is the one that supplies the what? The supplies the electricity, right? Then here, these two guys here, they are the what? They are the electrode. They are the electrode. Now they are the one that it's just like saying, I need something. It's just like saying I want to like shock, yeah. I want to shock this guy. So I've connected it to the electricity to the socket. Now these two things are used to hold the person by the side. These two guys here, they're like the electrode. So which means that they won't allow me the electricity to go from my own generator to the person's body or to whatever I'm doing. Do you understand that? So that's what this electrode does now. So these are electrodes now. Now we have two electrodes. We have the positive electrode, which is what? The anode. And the negative electrode, which is what? The cathode. The anode and the cathode. Copy? Now, so as this battery starts producing electricity, the electron goes like this. You know that the electricity in metal position is this is an electrolytic cell. So it's a metallic mode of electric production. So the electron goes this electron flow now. This blue one is electron flow. It goes like this. Goes like this. This is electron flow. Electron flow. Do you get now? Now, the opposite of electron flow is conventional current flow. Now, I don't know, can Jam ask it? Possibly. So let's learn it. This conventional current flow. That one goes like, it does anti-clockwise motion, unlike the electron flow. Now, since we got the anode and the cathode, so what is this dot thing? This one is the what? The electrolyte. They are trying to split. This electrolyte are trying to split. Now, what happened here is this. Let's say here, as the electron keeps on going now, let's understand what happens at the anode and what happens at the cathode. The first thing that happens at the anode is what? Anox. And that's what? Oxidation occurs at the cathode, at the anode. Oxidation. I'll explain what that means later. Then what happens at the cathode? Red cuts. Reduction occurs at the cathode. Keep that in your head. Keep that in your skull. Now let me see if you guys are still with me. What happens at the anode? Type it out in the comment section. ASAP boys. What happens at the anode? Type it out now. What happens at the anode? What happens at the anode? Correct, Rose Jane. Keep it common another person on the live class. Correct. Oxidation happens at the anode. I can actually say this big board has the disadvantage because it makes the camera far from the board and it makes it very tiny. Because even I myself trying to see through the screen now is not actually very easy. It's not actually very easy, but I have to just manage through. I think if I've learned that in my next class, I'll just have to like not use something like this again. It makes it very hard. And since my writing is not always that very bold, makes it very hard to control. It's all right. So now that's the first thing that happens there. Now, what does oxidation mean? Oxidation means what? Oil. And what is oil? Oxidation is what? Is loss of electron. Oxidation Oxidation is loss of electron. So then why in cathode, what happens there? Rig. Rig. And what's rig? Reduction is what? Is gain of electron. Is gain of electron. That's what happens at the cathode. No, you are wrong. They've been praised. That's cathode, not anode. Now, so you understand this now, the next one is this. If you look at the way electron is flowing like this, it goes like this, right? It goes like this. That means electron is entering to the electrolyte through where? Through the cathode. And see, it goes like this. Let me use this blue. It goes like this. And enters through this place. And then it leaves through where? Through the anode. So the next step of the cathode is what? Electron leaves. Electron leaves. That's what we got the word loss from. Oxygen is lost. So electron leaves through the anode. So from the word loss, leave. Leave and loss is at the anode. And what loss or leave is what? Oxidation. Why in cathode? Electron enters. Electron enters. Electron leaves, electron enters. Now, since this one is opposite of electron, what is this one? Conventional current, right? Conventional current. So yeah, conventional current, conventional current what? Enters. Please keep this in mind because, like I said, we don't really know what you tell me true or what that is when you're writing. We don't know what they will actually throw at us. We don't know. So for that reason, we have to be ready to know it from all angles. So while in cathode, conventional current leaves. Conventional current what? Leaves. You see, I have like two more points of what happened in the anode and cathode. I think it's a bit clearer now than before. Yeah, I think it's a bit more clearer. Oh, yes, I need to have a zoom though. So please, if you're not seeing, just zoom it. So I want you guys to jot that. I was about to rub that place off. Kindly jot it down. Try rub it off. So can I rub it off now? Okay, let's go then. Now the next thing here is this. I'm going to explain an example of an electrolyte here. So let's say, for example, now we have NaCl. NaCl is inside this place. And since NaCl now, immediately this electron, which is carrying the electricity now, enters into it, it will split or it will break down. It will split or what? Or break down. How does that mean? That means that it will dissociate into what? Freely moving ions. Na will become what? Na plus. This will become what? Cl minus. Let me write it more bigger. We have what? Na plus Cl minus here.
Now, what does this simply means? This simply means that what in this place, instead of us having dots, what we have here is what freely moving ions. I wrote down here, or I jotted down there. So in that scenario now, what will happen? The positive ion will go to the opposite pole, which is what the negative pole. So it will come here. Since it's plus, plus will go to minus because naturally, unlike charges what attracts. Then Cl minus will come here because unlike charges, which is negative, right? We attract. Are you seeing something here? So in that case, now it means that what the Cl minus is going to the anode. So from there, we have something we call anode ion or anode ions. So short form, call it what? Anions. So anions are formed in what? In the anode. So anions are what? Positive ions. How does that mean? Positive ions are formed in the anode. Sorry, negative, what am I saying? Negative ions, sorry, that was a mistake, are formed in the anode. The opposite of it, this one has what? Cathode ions. And that's what? Cations, from the word cathode and ion. That means that's positive ion. So which means that what? Positive ion are formed in the cathode. Now this is exactly what happened in the electrolytic cell. Make you understand this now. Now move to electrolysis. Jot that down, boys. Jot that down, boys. Okay, now let's move ahead now. So now we're done with the electrolytic cell now. The next thing we're doing is electrolysis of some substance. We're about to go deep into the real deal electrolysis. And let's do that now. So I'm going to rub up the board. So while doing that, I want you to play some music for us. Play Michael Jackson featuring Portable. So you can jot everything there down while we go to the next phase of today's topic. Electrolysis of some substances. Or before we do electrolysis of some substances, let me ask you some questions. Let's take some quiz again. General knowledge in science. Are you ready? For general knowledge in science, that's my second phone, so I can see your comments. Are you ready for general knowledge in science? If you're ready, drop an emoji if you're ready. Ready for general knowledge in science? Drop an emoji. Drop an emoji. I can't see enough. I'm not seeing very few here. Drop an emoji. Drop an emoji. Don't shower me emoji. Drop an emoji. Okay? Question. Who discovered hydrogen? Who discovered hydrogen? Write it down. Don't use AI. Who discovered hydrogen? Let's see the first person to get it. Don't use AI, don't use Google, don't cheat. There's no need of you cheating. That's the answer. I've written it. The answer is what? Henry Cavendish. Hydrogen was covered by Henry Cavendish. Keep that in mind. So write it down in your note. I've seen the question before in JAM, and it's possible they might ask it again. Nothing can be removed, or nothing can be pushed aside. So write that down, Henry Cavendish. So that was first gotten by, yeah, BJ. Network is bad. Olodo. I did not know it. Number two, who was the first person to design the periodic table? Who was the first person to design the? Who said Hydro Thomas? What year? I think that should be 1772. Henry Cavendish, 1772. Who was the first person to design the periodic table? Who was the first person to design the periodic table? I'm waiting for your answers. Okay, that was done by Dimitri Mendeleev. Dimitri Mendeleev. That's a very simple question, though. And from that with periodic table, you have seen that guy's name over and over again. So yes, Cavendish was officially the discoverer of the hydrogen. Yeah, that was 1766. Yeah, I know. Is it 17, no 1772? Oh no, 1766. 1766. I remember. Yeah, I remember because um it's not. I'm not sure it's 1766. That year is it should be around that 17 something or 1780s. So then after that, then this guy, what was this guy named Laviosa, named it, he called it hydrogen, meaning the water former. So I give you one more question. Yeah, Laviosa was the one that named hydrogen. Like they give you the name hydrogen from the a Greek word, water former. That 1766 is debatable. But I think I'll choose it according to what is in textbook. So okay, now for general knowledge, should I find this new trouble? I feel like asking them something outside. 1766 Abdul Malik. Let me mess with your brain. Let me ask you this one. In what year or who and in what year was this guy, neutron discovered? When was neutron discovered? When was neutron discovered? And that was very simple. It's just like few years before World War II by the students of this guy of Rutherford. Yeah, James. No, the year is wrong, BJ. The year is wrong. Abdul Malik, the year is also wrong. Don't give me 2 years. Give me 1 year. I'm sure of that. Abdul Malik and BJ, your years are wrong. Your years are wrong. That was 1932. James Chadwick, 1932, under the tutelage of Ernest Rutherford, when he bombarded beryllium particles to paraffin wax, or better still, just aggregation from beryllium into paraffin wax. Funny enough, the guy won the Nobel Prize using that, doing that. When it comes to no, don't let us shift. Don't let us shift. So I should go to atomic chemistry. We won't stop today. I think I'm done with your comments here. So in that scenario now, let's go back to our class. What is we are doing next? Since 1947, 1935, 1932. Kilo day is 1932. 1932. 1932. I've said it to 1932. James Chadwick. 1932. Other in Cavendish laboratory. That should be in England. Yes, England, I guess. Cavendish. That should be England. Do you guys get the answer now? Atomic chemistry. That's one of my favorite class. It's just that most times, I don't know. It's more of like story. And like, don't worry. One day we'll do it. One day we'll do it. Okay, let's go back now. What is we are going now? We are going into what? Into electrolysis of some substances. Electrolysis of some substances. I think this one around. We're using this place. So let me bring the phone here. Yep. Uh-huh. Bagam. Yes. This is what I'm doing now. Is there any comment for me? Now, this is it. There is something about electrolysis now. I want you to understand that electrolysis is like this. You see? Wait, is it clear? Hello, eh? Hello, is it clear? How is it now? Okay, I think it's better now. Now, let me tell you this. Remember I said that electrolysis is equals to what? Electrolysis is equals to what? Is equals to electricity plus what? Plus chemical change. That's electrolysis. This is what electrolysis means. Now, what is chemical change? Chemical change is just basically what? The composition of substance that is either what? In molten form or what? Aqueous solution of the substance into what? Into freely moving ions. Do you understand now? Do you understand what I just write down there? Into freely moving ions. This is not showing very well. Let's manage it. Now, when you do electrolysis on a substance that is in molten form or aqueous solution, it gives us a decomposed substance. But then let me first explain what does the word molten means, and what does the word aqueous mean. Molten just means that substance plus heat to become what? A liquid substance. That's molten. While aqueous means that substance plus water to become what? Become that substance solution. Let's say that substance is X. X plus water is what? X solution. X plus heat give us what? Liquid X. So in that case, it means that what? A molten X is a liquid X that is gotten by what? Heating X, or let's use Y. Oh, sorry. So a molten Y is a liquid Y that is gotten by what? Heating Y, which means a molten Y does not contain any other substance, not even water, because we turn it to liquid by what? Putting it on fire. While an aqueous Y is a Y that's gotten by what? By adding Y to what? Water. By adding water to what? Y. So we call it what? Y solution. What do you like, Abdurrahman? Wait, oh, I don't understand. Wait. I think I've seen some comments. BJ and Abdurrahman, what did you see that make you say this man too good? What did I say? Oh, just like discover what? Abdurrahman is Jesus. How many messages that I've never seen before? Okay, Abdurrahman, James Chadwick discovered neutron in 1932 under the guidance of Ernest Rutherford. That's in Cavendish Laboratory, so I believe that should be England. Story. Long story cut short. He shall do radiation from beryllium. He bombarded into paraffin and blah 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 shit like that. So that's just the story about the Chadwick. Then who again? BJ, I mean, who say sharp? Who say enjoy? Okay, yes, sir. Enjoy sharp. Then so say this man too good. BJ, what make you say this man is too good? What did I do? What did I do? I'm interested to know. I want to know the reason why he brought that up. I know I sabi. Thank you, Shei about it. I know I sabi, but I'm curious I'm curious of that reason. The next person said the up part. What's the up part of the Rahman? Okay, what, can you see it now? Then Koyim said, "Sir, we're almost done. My data is acting up. Don't worry. All of the 13 of you, write your name down in this comment section. You are getting a free sub for Thursday and Saturday class, or probably Saturday class. You're getting a free sub for everybody. Yeah. Abdurrahman has the highest XP for today. Ololokpe second. Wow. Omo Naya third. Living praise fourth. Jesus Christ. Omo, I get plenty XP today. Oh. Sanusi Emmanuel was even here. Gani was here. Slavo Delice was here. Okay. No, that's not the meaning. That's not the meaning, BJ. I've seen yours now. I've seen yours now. That's not the meaning. Hey, what have I done? Oh, Jesus Christ. Okay, that's not the meaning. Now, the molten here, you see this molten here is a trap. Like, I was very exhausted, but my exhaustion was not from the teaching. After I take 4 hours class, my exhaustion was the discovery that I came to this place of this big board and then realized that the big board is a disadvantage, especially when there is no one controlling the zooming for me, or like when there is no one actually moving the handle of my tripod. So it's a disadvantage. And guess what? We started this class very late because I wanted to use the big board. I'll use the other small classes. So that only that it makes me, I don't know, it makes me mentally weak. I can't lie to you. You know, everything I'm teaching is from here. I mean, I can start doing, let me even do it safe. Look at, let me move camera a bit. Can you see? The only thing you will see is the bread and rag and my bag and the water and the board. I don't see anything books here, nothing. I don't need any book. Can you see? And if you look at my phone, the second phone, you can see that what's there is what? The YouTube. Can you see? So there is nothing. I actually don't need a book. No, I'm not saying using a book is bad, but for me, I don't need it. And I think I'm grateful to God for that. So, but jokes apart, my mind is not settled due to the fact that discovering that coming here did not actually even solve what I want. Was all my mind. So all my mind is on the concept that okay, what can I do if I want to use a big board in a class? If I want to use a big board in a class. How can I make it that the student can see it? And there is no way I'll do it. Consciously, my writing is tiny or small, consciously. So I can't remember to be writing this bold all the time. So I think probably henceforth, I'll just use the other board in that class. That's just, it messes my mind up a bit. But nevertheless, we'll get better with time and we'll move ahead. So I think which other one again? So yeah, so this molten here, I want to say something here. This molten here is a very crucial aspect. There are two guys that makes you miss questions under electrolysis, questions that under electrolysis but not calculation. Is this molten here and the electrode used? Because the electrode used can determine how the product will be formed or be liberated. So the molten or the aqueous can determine it. Because even see this aqueous also can even Jesus. Oh, I wish I'm in the flying mode. Like for example, you see, aqueous NaCl using a particular electrode can through aqueous NaCl have a high chance, not a medium, an average chance or small chance, have a high chance of giving you different products. I don't know if you get. If this aqueous is diluted, it's concentrated, we use. Oh Jesus, I'm jumping. Don't let me jump. Don't let me jump. Don't let me jump. Because don't let me jump. But it's not be good if I jump. So that's just the point. That's just the point. Just understand it today. Molten just means Y plus heat equals to liquid. Y just means Y plus water equals to Y solution. So you can jot that down. I must not miss this class. That I beg recap. I don't understand where I said to recap. Swears. Peace up, thank God. Call you more the swears. I must not miss class. Yes, I got to know it today, okay? You learn every day. I'm always on my I don't go missing. No, no I ain't go missing. I'm not go. My phone is already go. Okay, so let me just finish the electrolysis of sodium chloride and then wrap up with the class and then we'll continue there on Thursday. Meaning on Thursday, we'll see the chemistry. So, Sunday and my Saturday and Sunday will be biology and physics. So, I'm using XR and it's getting hot. One one. There is next time. What are these Android? What about height there? Olodo. No need Bukoya now. Oh, Olodo. This self na small time remain. Is that all? My phone won't blow. I'm like, yo, I'm not using my mom phone. Ah, Jesus, hot plate. Please don't leave, sir. Okay, please don't leave. Probably his phone or something. The motive stuff, my network was skipping. Don't worry, you know it in the future. Okay, so let's, I don't know. Let me see how many comments now. How many of you want us to close here? Or you want us to do the electrolysis of molten NaCl? So if you want us to do an electrolysis of molten NaCl, of molten NaCl, just type yes. If you want us to continue, if you want us to stop here, stop before we do this one and continue on Thursday, type no. So let's go. Drop your comments now. The fast boys. So you want us to do molten NaCl this night before we close, type yes. If you want to close here and continue on Thursday, type no. Though that means we can't do the electrolysis in the air because we still have a long way to go. We have a long way to go because we need to do all these ones and still do calculations also. Oh yes, I've seen one, I've seen two, I've seen 2-1. Oh, I've seen 3, I've seen 4-3. No, cause me mentally you're mentally unstable. And then go to bed now. What you see here? Yes, do that body. Nice one. So let's close. My phone is too hot. I swear, this guy is the most funniest comments. What the hell are you using your phone for? Put inside water. I don't partially sleep. God, I wish this can be cut out. I don't partially sleep. Wake up. Network unstable. Me say they feel the class. Nice one, eh? You say no. Why is Mama Clever laughing? Oh, she's students. I don't partially sleep. Wake up. Yeah. Oh God. My phone battery is low. Okay, your own phone is not hot. Your own phone is low. Okay, I don't know. I'm actually. Oh, you know what? Let's wrap it up. And then in the next 6 minutes, by 11:30, we'll close the class. But let's do the definition of molten NaCl first before we go to bed. This topic long, shall it's long. I know the issue with electrolysis is that every single aspect of electrolysis, like every single part is important to understand. So you can't only jump anyone. I don't know if you get. Like I'm taking a tutorial, a physical tutorial somewhere. I'm doing electrolysis for like 3-4 weeks. I'm not even finished it. but after them, I'm not teaching it again. So, like, you need to learn electricity of different substance. You learn it from the molten angle, you learn it from aqueous to dilute angle. Let me even come to the front so you can see my face. So you need to learn. You see, as electrolysis is the only topic that introduction aspect or introductory aspect is important. Like electrolysis is the only that introductory aspect is still as important as the ending part. So after you understand introductory aspect, you now go to what the terms. Where you will learn electrode, cathode, electrolyte, which is what I did there. Then after you now do that one, you now move to what? To what is it called? Ionization theory, which I skip it because ionization theory, Ionos theory. That was in 18, I think 1878 or 1880 something, I can't remember. Yeah. So you now go to this one now. Now, after you know this one, and this also is very, very important. To make you understand the concept behind the acid dissolution and the Unix dissolution. And now from here to what? Now from here to this one, EOS, electricity of substances or substances. Under this one now, you now do it in three different angles. You do it in two different angles from here to here. You do it in the molten angle and the what and the aqueous. So now the aqueous we now have two. We now have dilute aqueous, we have concentrated aqueous. So now aqueous now come to this place. Now let measure the side of the ions, which is PG what is it called? PDI. Under PDI now you now learn what? You now learn position of ions, you will learn COI, concentration of ions, you will learn NOE, which is nature of electrode. So now each of these guys are seen here, each of them needs like 30 or 50 minutes to treat everyone. After I'm done with all these ones, now go to electrochemical cell, which is where you now be learning about what salt bridge, electrochemical series and what is it called, and co and co, or voltage ratios. So that's I see that thing. Let me see that. I don't know if it's showing. See that cycle I draw there. That thing is war. It's in my head was moving smoke. So that's just the concept around it. But actually, so it's I want to make it like a long class, a class that I will be doing continuously, non-stop. I don't want us to be again because I know I'll not be able to like get the vibes again. So, but don't let us waste more time for those that their phone is low. Let's do more next year and then to close for the day. And we'll meet again on Saturday, on Thursday. That Thursday, we'll do revision the first 15 to 20 minutes and then we'll go deeper into it. So please invite all your friends, invite everyone. I want that day to be very massive. All this issue of light and everything. On Thursday, it's not be like that. By the grace of God, better than this. So let's do it now. So I want to give you some nuggets, some fast nuggets I want you to understand. Now you see those things you write down earlier, those association of card, blah 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 shit. See those ones, they are for simple OBJs. Is there any message? People are not getting, they're not coming back. What happened? Who is Faramini Femi? Wow, welcome Faramini Femi. I'm seeing your name for the first time in my life class. For the first time ever. Some names have been constant in my life class for like only God knows. Why some name? That's the only new name I can see today. 11 p.m. to 2 a.m. Wow. Yes, I won't forget your what is it called? I show science. Abdul Rahman. Yes, that's our tag. That's our tag. Now Malik go first. Now Malik go first people. Okay, let's do guys. Let's do multi here, boys. Yay! That's gonna be massive. On Thursdays, midterm break. So all the students are not going to school, they'll be at home. So share the link of the electrolysis. We call it the Irakpada or Irakpada of electrolysis. Share it to every student around you. Share it to all the what is it called? To your younger ones in SS1, no, SS1, SS3. Are you ready? So share it, please. Oh, it's not showing. Thank you, Rosen. Thank you. I'll take it off now. I think it's more okay like this. It's okay like this, right? So let's do it now. Uh, Now, before we do molten energy, let me explain something to you that happens in the anode. You see, it happened. Jesus. Oh, these are my marker. No wonder. This marker not good. And it's new. I don't know if it's going to write it. So what happened in the anode? What happens in the cathode? First thing first, you're doing an anode oxidation of pulse, right? Can you hear me? Now I'm about to enter mood. Are you ready? Don't chat again. Don't drop any message again. Let's enter class. Don't chat again. Let's enter class. Sorry, Rachel. Sorry. Put ice block on your head. Let's go now. Are you ready? So what happens in the anode? What happens in the cathode? Now I'm about to go ghost mode. Welcome to the I show science quantum navigators. You see, it's like this. Electricity is a flow. Is a what? A flow. You know, let me be very honest with you if you're here in this class. Everything that is a flow can never stop. Like that means it can never like be exhausted. We can't use it up. That's exactly the reason why you see God created the natural resources to be in the flow format. You get the point? Some of you were in my paid class yesterday when I was taking astronomical chemistry. I told you something about sun. There's a way the sun works. If the sun was using a burning method, if the sun was using a burning method, trust me, we will not have sun for this long. The sun has been there for over a million, 5 million, 10 million years. But because it used the process of what we call nuclear fission, a radioactive method whereby one split into two, two into four, four into eight, and that eight keep on splitting, and they keep on splitting, and they keep on splitting. They can keep on splitting for as long as possible, and then the energy will keep on what blooming and booming and booming and whatever moving, what is moving. Same thing with river. River flow from ocean, I say river water. From ocean to river, river to spring, spring to but that's the ground. Oh. Then the ground now, you see, the plants taking water, the animals taking water, then all of us still release water. Then water goes to the sky. Then the sky gather the water as what as cloud. Then water come down. What do you call it? It's water cycle. So it keep on flowing and keep flowing. So in that flowing, we have what? Dirty water, we have clean water, we have muddy water, we have rocky water, minerals water, rain water. So it has not source of water now, types of water. And the way it keep on flowing now, that your dirty water, can I tell you the following thing? Let me shock you this evening. Before I teach you this, let me shock you. You know that the water you're drinking in your house is your toilet water. The water you're drinking in your house is your toilet water. Some of you put your septic tank, you put it here, and then your water tank is here. Now, according to science students, can water diffuse, and want to get to this place, and then goes up. Oh, are you getting the point? So the water that you are using, you are what is it called, you are drinking, is actually your toilet water. But the thing is, when you get to the toilet water now, yes, when the toilet water come back to the water enter your tank, it has gone to another process again. That before you know it got already recycled on itself without any man-made movement or man-made work. Now in that scenario, now back to these beings, beings. So as electricity is in a flow, is in a flow. In fact, we call it what? We call it cycles. If sorry, if 3 ampere go, what we get is what is 3 ampere. If 4 volts go, whatever you're using mention, I'm not actually teaching electricity now. So what I'm driving out here is this: is that it's a circular motion. In the sense that whatever is lost here will be gained here. Whatever is gained here will be lost here. That's the way it is. So that means now, since electricity is actually gotten from the what electron flow in a metallic conductor, it means that we are dealing with what with electron movement. So that case now, whatever electron that was lost here, because in and what would we do? Electron loss. Electron loss. Whatever electron that was lost here, we what will be gained here? Electron gain. In that case, if we lose 5 electrons here, we get how many electrons here? 5 electrons will be gained here. I don't know if you get the point. If you lose 5 electrons here, you get how many electrons here? 5 electrons here. If you lose 6 here, you gain 7 here, 6 here. That's the way it works. That let that be in your head. It will help you what we call the half reactions. Sorry, it will help you what we call half anodic reaction, half cathodic reaction. Copy, copy. Hello, hello. If you actually go and buy processed water, the processed water is still also toilet water because they are all collected under the soil. All of you are eating, you are eating a dead man's skin. Man died. Man turned to decay matter like nutrients, right, to the soil. And then when it comes to nutrients in the soil, you are able to the bitter leaf, you get the nutrients. You're not a dead man. You're all eating a dead man. All of you are what? You are dead men. The biggest dead man is there is Pablo Shaitan. That boy is a dead man. Oh, you are all dead men, say. You didn't know what was going on. Our life passes on TikTok. Prepare for it. If you are on this live class, how many of you in support to our TikTok session that you want it to be TikTok? How many of you? How many of you in support of TikTok session? How many of you in support though? You guys are please download TikTok and join the class that day. Please download TikTok. You don't have to give me gifts. Tap tap tap. They will give me gifts now. And yes, you have actually been receiving a lot of requests about TikTok. For real, I'm not joking about that. And that's why I dropped that vote that day, and we have more YouTube votes, which was why I just ignored it. But I think let's try TikTok once and let's see what is there. You understand? Let's see what is there. Let's approach students then. So I know that most of you, I told you guys not to use TikTok because of the distraction. You can just download it, finish using it, and then freeze it. It's either you freeze or you lock. A many app locker. In fact, I think I even lock some app under file manager. I don't know how iPhone works though, but you can actually download a freezer or a app locker, then lock it when you are done with it. Yes, if you actually delete your TikTok, that means you're my students. It means after all what I've said. No, 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 no. TikTok, Facebook, and YouTube consume the same amount of data. Yes, TikTok, Facebook, and YouTube consume the same amount of data. Amount of data. Yes, call you buy a piece. If you buy a piece, it better. The cars out of you are pretending, no. Abi what will I do? Let's take it to what is it called to TikTok. You understand? Please, if you're using ITEL like Sheyi Body, please don't join us. Okay, I think I'm done now. That's all. So anodic half reaction now. Now what happened there is this. You see, let me draw a sketch here. I don't know if this place is showing though. Wait, let me see. Is it showing? Is it showing? Oh, it's showing. Good. Now let me draw a sketch here. Remember that we have, let's say the anode is here. The anode is here, right? And the cathode is here, right? Don't forget about it. And the thing is there. So what happened here is the Cl minus go to the cathode. Hey Jesus, what have I done? Ah, sorry. Voila, that was a mistake, a terrible one. Cl minus goes here. Na plus goes here. Yeah, sorry. So Cl minus will come here, right? Cl minus is here. And then Na plus is here. Now remember that what happened in the anode is what? And in the cathode is what? Gain of electron. Gain of electron, right? Meaning Na plus will gain electron. The what happened in the anode is what? Is loss of electron, right? Then meaning that what? Cl minus will lose electron. Do you remember? Do you remember, yes or no? Do you remember? Are you with me? Do you remember? Say you run T, show run T, say you run T. So that's what happens in the anode, right? Okay, this guy is still charging. Are they there? Okay, thank you, Dorcas. All Dorcas is with me. He said, I'm already feeling sleepy. I can teach from now to around 3 a.m. You guys don't know me. Let's continue, please. So let me just wrap up. We'll soon be done. Now, that's what happens in the anode now. Cl minus going to gain electron. So Cl minus. Now look here also now. Look here. Cl was 287. Then Cl gained 1 electron to become Cl minus, and that becomes what? 288. So Cl minus will lose that 1 electron, and now Cl minus equals to what? Cl plus E minus. So yes, 287 equals to what? 288 plus 1. Sorry, 287 plus 1. And so that means that what? Cl minus lose 1 electron and become what? The normal Cl. This will happen in the anode. Cl minus lose 1 electron and become what? Normal Cl. So 18 equals to 17 plus 1. It's not balanced. 18. But then Cl cannot be alone, so it's Cl2. That's chlorine gas. So let's balance it now. 2 here, 2 here. So in that case, how many electrons was lost in the anode? How many? Write it out. How many electrons was lost in the anode? Yeah, correct, Abdul Malik. Correct, Rose Jane. Another person? Correct, Dorcas. Correct, small boy Clef. Correct, Olabode Rachel. Correct, Tinubu. Correct, Buhari. Correct, Shetima. Correct, Dakwabiolu. Correct, Shawolu. Correct, Donald Trump. I have any president here. Correct, oh Jesus. Correct, Xi Jinping. Correct, Donald Trump. Oh, many presidents. So now this is what happened in the anode. So in conclusion, what happened in the anode is what is how many moles of chlorine gas is liberated? My students, so yeah, answer the question. How many moles of chlorine gas is liberated? Yes, correct. Allow me to praise. Yes, we are going to gain those 2 electrons in the cathode. You are correct. Okay, we're doing 2 moles. Abdulrahman, 2 moles. Olabode Rachel, 2 moles. No, that's wrong. It is not 2 moles. It is 1 mole. Now, let me show you what mole means. It is 1 mole. Let me show you what moles mean. So equals to Cl2 plus E minus. Right? Now, moles is the number that is here. The number that is here is what we call moles. When there's no number there is what? 1. When there's a number there is what? 2. And so when there's no number there is 1. So correctly there's no number there, so it's what? 1. So that means 1 mole of what? Chlorine gas is liberated. 1 mole of chlorine gas is liberated. Yes, I balanced it, Rosjane. Have you seen it now, Rosjane? And Rachel and Abdurrahman, have you seen it now? Okay, continue. So let's do what happened. Let's do for anode cathode. I'll hold the board in just 10 seconds. 10, 9. Is the board not showing? Ah, sorry. So that's what happened in the anode. 1 mole of chlorine gas is liberated. Yes, I've done that. So please let's be fast. Okay, let me do the anode here. Let me do the cathode here. So in the cathode now, cathodic half reaction. So now Na plus goes to the cathode, right? That will be, and what will happen in the cathode is what? It gain electron. That will be Na plus. Let me see if it's showing first. So if I start blasting, it's showing. Is it showing very well? Yay, voila. Okay, so now Na plus, we gain electron, right? That's Na plus plus E minus equals to Na, right? But how many electron was lost in the anode? 2. So let's put 2 here. 2 electron here. Now, for some people that are very confused like me, normal Na is 281. Na plus is 28. So then how many electron is here? 2. Right? Or better still, before the 2 is here, how many electron is here? Is 1. So 28 plus 1 is 11. That's already balanced already. Let's do the normal balancing. So put 2 here. Why am I putting 2 here? Because in the anode, 2 electron was lost. So this is it. 2 here. 2 here. Right? So now, if 2 is here, what we'll do is we'll put 2 here. Put 2 here. So it's balanced now, right? So we have 2 Na. So we have 2 Na, 2 Na. 2 charges, 2 electrons. So with that being said now, I think that is clear enough for us to understand. I want to ask you one question. Write it in the comment section now. What happened in the anode? If 1 mole of chlorine gas is liberated in the anode, what happened in the cathode? Hey, voila, wait. So what happened in the cathode? Okay, how many doesn't understand? So I can recap it, I can explain. How many doesn't understand? If you don't understand, signify. So we just run it and then we go. How is 22, 8 and 2, 8 and 1 is 2, 8, 1. What's 2, 8? 2, 8 is 18 now. It's not 2, 8, it's not 28, though. It's 2, 8 like configuration. 2, 8, 2, 8, 1. Kelement shell. Do you understand now? We're going to have an issue. Okay, what do you understand? In the anode, chlorine neon goes to the anode. Chlorine neon forms chlorine gas by getting 2 electrons, right? In the cathode, sodium ion gains 2 electrons by forming sodium, right? Now, how do we know I get 2 electrons? Because in the anode, 2 electrons was what? Lost. Are you a bit clear now, Abdurrahman? Are you clear now? Yes, you are correct. In the cathode, 2 moles of Na is liberated. Okay, thank God for that. So, ladies and gentlemen, let's meet on Thursday on TikTok. The chances are TikTok. 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 I've asked the question already. I've answered it already. So, bye bye. Bye bye. Video. Can I go, sir? Who's asking me? Or you? Yes, you can go, sir. Let's decide subject. Let's do it. What's this one typing? Shall us drop link. Is it for TikTok? I don't know if there's TikTok link. I don't know how TikTok works, so, but there's link. We'll drop it, and there will not be issue like today's one that we actually got delayed and then everybody disappeared already. So it's not happen again. It's not happen on Thursday like that. So with YouTube, you will know. With TikTok, you will know. Can we play K-Woods? We can't play Kahoot on. You want us to play Kahoot? Let's go live on TikTok now. I don't want to play Kahoot. How many want to play Kahoot? Ó ti pẹ́, who was this one typing? Ó ti pẹ́ tí, hey Jesus, ó ti pẹ́ tí a ti ṣe Kahoot. Oh, no, no, Yoruba. I'm not doing. Malik said I'm not doing. Kahoot, the say yes. Rizin say yes. Malik say no TikTok. All right. We're not doing Kahoot here. If I want to do Kahoot, it has to be TikTok. It can't be here. So I'll see everybody's screen. See we say phone results. Let's go and do Kahoot. Even XR user is shouting Kahoot. Please, hello. If the class end by 12, go and study till 2 a.m. Everybody going to tutorial is going by tutorial at 10. So you can study till 2, 3 a.m., sleep by 3 a.m., wake up 8, bathe and get to tutorial by 10. So no Kahoot on no TikTok. No, today Kahoot now. Yes, it has to be on TikTok. We are going live on TikTok. Then we'll play the Kahoot there. I'm not showing my face, so I don't have the strength to show my face right now. I beg, I don't get TikTok. If you don't have TikTok, I don't do Kahoot too. Guys, I'm going. Other boy, thanks for being here. I mean, almost everyone on this live call or live class is mostly my students. So that means you don't have any new human being. They're only old, poor human beings. Okay, everybody, thank you. Bye bye. I'm going. How does you cancel this thing, sir? That's you.